All right, let's just jump right in. Today, we are going to tackle what might be the single worst prediction in the entire history of physics. Seriously. And we're going to explore a totally new way of thinking that might just fix this whole cosmic catastrophe.
Just take a second and look at this number. That's a 1 with 122 zeros after it. I want you to imagine you tried to predict your monthly electricity bill, okay? But your prediction was this many times higher than what you actually owed. That is the scale of the error our best theories of physics make when they try to calculate the energy of empty space. It's not just a little off, it's mind-blowingly, universe-breakingly wrong.
And hey, don't just take my word for it. The legendary Nobel laureate Steven Weinberg looked at this problem and called it a veritable crisis. So this isn't some tiny little academic squabble. It's a fundamental breakdown in how we think the universe works. So what on earth is going on?
Okay, so where does an error this gigantic even come from? Well, the prime suspect is actually one of the most successful theories humans have ever come up with, quantum field theory. Let's dig into why our best theory fails so spectacularly here. Quantum field theory, or QFT for short, is basically the rule book for all of modern particle physics. And when you ask it about the vacuum of space, it gives you a very clear, very specific instruction. It says the energy of empty space is just what you get when you add up the bare minimum background hum, what physicists call zero-point energies, of every single quantum field in the universe.
And this right here, well, it's a recipe for absolute disaster. The logic seems sound at first, right? QFT tells you to add up the energy of every possible little vibration, for every field, at every possible energy level, all the way up to the absolute physical limit, the Planck scale. The problem? When you add up a near infinite number of things, you get infinity, or a number so big it might as well be.
And this analogy just perfectly nails the problem. See, QFT isn't just getting the math wrong. It's using the wrong kind of thinking for the job. You would never, ever value a house by trying to price every single atom inside of it. That's just absurd, right? QFT is basically making that same mistake. It's treating the whole universe as just the sum of its tiniest little parts, and that seems to be where it all goes wrong. So here it is in black and white. On the left, you've got the insane number that QFT spits out. And on the right, you have what astronomers actually measure when they look at how the universe is expanding. The difference between them isn't a small gap. It's that 122 orders of magnitude chasm we started with. It's a complete and total failure of the theory.
But what if we've been looking in the wrong place this whole time? Let's check out a completely different way to think about this, one that starts from a much simpler idea, the geometric solution.
You know, the key insight here is nothing short of revolutionary. It says, forget about adding up an infinite number of tiny quantum jitters. Vacuum energy, the thing we call the cosmological constant, it isn't fundamentally a quantum thing at all. It's a geometric thing. It's a basic property of the overall shape and curvature of the entire universe.
And this idea leads to a formula that is just beautiful. It's so elegant. The cosmological constant, lambda, is just some simple constant divided by the radius of the universe squared. That's it. No infinite sums, no weird quantum corrections, no arbitrary cutoffs, just the size of the cosmos itself.
Okay, so now we have our two competing ideas. In one corner, the old, complicated theory that fails spectacularly. And in the other corner, this new, simple idea that seems, well, really promising. So let's put them side by side and see what happens.
I mean, just look at the difference here. On the left, you've got the QFT formula with that scary summation symbol, which basically means add up an infinite pile of things. On the right, you have the geometric formula. It's clean, it's simple, it's holistic. It connects the vacuum energy not to all the little tiny pieces, but to the biggest thing there is, the universe itself.
This table really breaks it all down, doesn't it? QFT is all about summing infinite energies, and it needs this random, arbitrary cutoff point to even work. The geometric approach? It just looks at the curvature of space-time and has a totally natural cutoff, the size of the universe. One of these is completely plagued by infinities. The other has none. The entire way of thinking about it is different.
And here is the big payoff. This chart shows you just how wrong each prediction is. The bar for the QFT error is so big you literally can't even draw it. It's 10 to the power of 122 times too big. And the geometric prediction, get this, it's only about 14 times too big.
I mean, just let that sink in. We've gone from the worst prediction in the history of science to a number that's in the same ballpark. This is more than just a better answer. It changes the entire game. It takes a veritable crisis and turns it into a puzzle we might actually be able to solve.
So, what are the bigger implications here? Because this isn't just about getting a number to be less wrong. This suggests a really profound shift in how we should be looking at the universe.
You have to remember, this problem has been haunting physicists for over half a century, and when the discovery of dark energy happened in 1998, it just confirmed that the crisis was very, very real. For decades, there was almost no progress. But now, for the first time, these geometric ideas, they offer a genuine path forward.
What we're really seeing is a clash of two different worldviews. The QFT view is what you'd call bottom-up. To understand the whole, you have to add up all the infinite tiny little parts. But the geometric view, it's top-down. It says that the large-scale structure of the universe is the primary thing, and that structure is what determines the fundamental properties we see.
And that right there is the biggest lesson of all. When your calculation is off by a factor of 10 to the 122, the problem isn't a misplaced decimal point. It's a sign that the entire foundation of your thinking, your whole conceptual framework, is just wrong. You're not just in the wrong city, you're on the wrong continent.
So what's next? Well, being off by a factor of 14 is still an error, but it's the kind of error physicists love. It's a clue. It's a puzzle they can now get to work on. Maybe the universe's overall shape, its topology, needs to be factored in. Or maybe there are some other geometric effects. The point is, the real investigation can finally get started.
And all of this leaves us with a really deep and fascinating question. If the simple geometry of the cosmos, its shape and its size, can solve the most embarrassing problem in modern physics, it just makes you wonder, what other profound secrets of our reality are hiding not in the quantum foam, but in the grand, elegant geometry of the universe itself?